Okay, I think let's get started. I'm really looking forward to this. I'm very excited to introduce Professor Jason Plaks. He's an associate professor with the Department of Psychology here at the University of Toronto and one of our newest faculty fellows at the Institute. And in this seminar, Jason is going to describe his recent work towards developing a comprehensive model of the psychology of human-robot trust. And that's just such a critically important topic. I'm very excited to hear about this research. Jason received a BA from Princeton University in 1993 and a PhD from Columbia University in 2001. He taught at the University of Washington from 2001 to 2006 and has been a faculty member at the University of Toronto since 2007. He is a fellow of the Society for Experimental Psychology and the Society for Personality and Social Psychology, and a consulting editor for the Journal of Personality and Social Psychology, the Journal of Experimental Social Psychology, and Personality and Social Psychology Bulletin. Research focuses on uncovering folk beliefs that form the foundation of moral and political cognition. So I'm really glad to have you here, Jason, and please welcome me in joining him. Looking forward to hearing your talk. Thanks, Jason.
All right, thank you. Let me bring up my screen. All right, well, thank you so much for this opportunity to share with you some new data, not published yet, on the psychology of human-robot interaction. And so I'll frame the talk by invoking two of the most famous robots ever to appear in film, R2D2 and HAL 9000 from 2001 Space Odyssey. And so R2D2 is a loyal, trusted companion. HAL is a creepy, menacing entity. And the filmmakers do a great job of conveying these attributes to the viewer. But what we in my lab are trying to do is look a little more closely under the hood and begin to identify more specifically what are the cues that promote and impede trust in robots. So let me just back up a step by mentioning that in general, people have a hard time fully engaging with machine actors, despite potential societal benefits. And a lot of this work has been done with respect to autonomous vehicles. In the not too distant future, probably you and I are all going to be riding around in cars that drive themselves, but there does seem to be at the moment a good deal of popular reluctance to adopt these technologies. And so because of this kind of reluctance, it's really spurred a number of researchers in the field of HRI, or human-robot interaction, to begin to attempt to identify what are some of the variables that represent barriers or enhancers of human-robot relationship building and trust. So a major theme of this literature has been to focus on the psychology of anthropomorphism and some of the effects of anthropomorphism on relating with machine actors. So one relatively early study in this literature by Waits, Hefner, and Epley reported that adding a name, a gender, or a human voice increases trust in an autonomous vehicle's competence. So this was some initial evidence that kind of humanizing the machine in some way increases trust. But many of you may be familiar with this figure. And so this is a representation of what's known as the Uncanny Valley, a concept that people in HRI are constantly dealing with. And it's the idea that as on the x-axis there, as the robot becomes more human-like, for a while we like it more, but then there's this dip where we find it unsettling and creepy before ultimately our liking of the robot increases again as it becomes more human-like. Now, my understanding of this literature is that for a number of years, whether or not the Uncanny Valley truly existed was controversial, but I at least have been convinced by a paper published last year, a massive multi-site paper headed by Maya Mathur of Stanford University and various others, in which they provide this evidence that the Uncanny Valley does seem to exist. And just for your edification, here are the actual stimuli that they used. So on the bottom row there are actual humans, but every row above the bottom are robots that vary in the degree to which they are more robot looking or mechanical looking versus more human looking. Okay, so this is an interesting consideration to keep in mind as we're doing this kind of research. But one thing that's sort of occurring to us is that, is this really the question we want to ask? In other words, we suggest that varying the physical features of a robot is, at best, an indirect way of assessing the real questions about the robot's quote unquote psychology. Consider that, HAL from 2001 Space Odyssey didn't even have a body. All he had was that infernal red light. And yet the Kubrick was able to convey this high degree of menacing creepiness. So this has spurred us to try to look beyond physical anthropomorphism and begin to ask the question, what makes something appear to have a human-like mind? And there is, believe it or not, some work on this, although surprisingly little, I think, in social psychology. And so here are some of the authors that have investigated some version of this question. So one early paper by Gregory and Wegner had participants do pairwise comparisons, kind of ratings of different pairs of entities. So for example, a robot, an infant, a chimpanzee, like in various paired up combinations. And from those ratings, they could use a statistical technique known as multidimensional scaling to extract what are the main dimensions along which people organize these things. And they gave names to these labels. Two dimensions did emerge, and they called them experience and agency. Later, Reisman and colleagues used a different method and a different statistical technique, and their results spit out 3 dimensions, which they labeled mind, body, and heart. Mallet and Magar used yet another technique and another statistical technique, and they came up with 4 dimensions. Haslam and other research came up with 5 dimensions. So there's clearly no set of agreed upon number of dimensions, or the key dimensions of what makes something appear to be human. So what my students and I have done is try to consolidate some of these ideas and looking across the different models and try to pick out those ideas that are in common. And so from that, we came up with a list of 4 dimensions, which we call the VAS list. And so VAS stands for values, autonomy, social connection, and self-aware emotions. So by values, we mean the entity holds positions about right and wrong. Autonomy means it makes independent choices, can make mid-course corrections. Social connection means the entity makes friends, it can value others, and self-aware emotions means it experiences and perceives more complex types of human emotions like shame, pride, and nostalgia. So that's on the independent variable side, but we're also interested in moving a little bit beyond liking on the dependent variable side and moving to trust in particular. And this is where it dovetails with a lot of my prior research in moral psychology. Trust is the foundation of morality. There's been a ton of work suggesting that cooperative behavior is more likely to the extent that people trust that they will not be exploited. And people are more likely to place trust in those perceived to be similar to themselves in relevant ways. So one common way to assess trust in behavioral research is to use a prisoner's dilemma. And I'm sure you've come across some version of this in the course of your careers, but the basic idea is that 2 interdependent players make a series of cooperative or competitive decisions in an attempt to win as much money as possible. And so here's the type of payoff matrix that you might typically see, and this is what we actually presented to our participants. We told them to imagine that they were the executive at a large company, and they had to choose a pricing scheme for their main product moving forward. And they could choose either the standard scheme or the discounted scheme. The standard scheme is kind of the safe bet, and the discounted scheme is intentionally undercutting your competition, trying to set a lower price than the competition in order to lure away customers. And that scheme only works if your counterpart, your arch enemy company, also doesn't do that. So you can see there are 4 options. So if you both play the safe route, you both get 5 million. That's kind of the top right cell there. If you choose the discounted scheme and your counterpart chooses the standard scheme, that's where you're screwing your opponent. And that's this kind of screwing your opponent's cell is going to be one of our main dependent measures of interest. If you choose the standard scheme and your opponent chooses the discounted scheme, then you're the one who's being screwed. And that's the top right cell there. And if you both try to screw each other, you both wind up winning less money than if you had both played it safe. So this is kind of the standard arrangement in the prisoner's dilemma. So each player's decision in each round is based in part on a prediction of their counterpart's next move. And so the thinking in a lot of this work is that people are more likely to choose the cooperative option if they trust that their counterpart will not exploit them. So, believe it or not, there have been a few studies in which participants were brought into the laboratory and asked to play prisoner's dilemma with robots. So one of those studies from 1996, Kiesler et al., they provided evidence that sustained interaction over an extended period of time, it increases the likelihood of participants choosing the cooperate option. And more recently, Sandoval et al. Found that participants tended to engage in a tit for tat with a robot. It's kind of like, I'll scratch your back if you scratch mine type of relationship with the robot. In other words, in both of these examples, participants appear to enter into a kind of implied social contract with this machine. But the independent variable in all these studies is always kind of robot versus human. And what we're interested in doing is trying to see if we can alter the robot's quote unquote psychology and in turn manipulate its perceived trustworthiness. So here's what we did. Participants played 2 rounds of prisoner's dilemma game against either a human or a robot. But the full design was as follows. So they played either a human or a robot that was presented information along the 4 vast dimensions of values, autonomy, social connection, or self-aware emotion, and either a high or low level. So they could either express high values or low values, high autonomy or low autonomy, high social connection, low social connection, etc. So we have this kind of full factorial design. I'll talk a little bit more about that as we move along. But first, you might be thinking to yourself, how did we do this during a pandemic? And the answer is we had people, paid participants, log in to an online kind of data gathering platform in which they were told they're going to play prisoner's dilemma against, for half of the participants, they were told they're going to play against another participant. And this is actually just a research assistant posing as another participant, or they're going to be playing against a robot. But prior to the game, they were told that we're going to have a little getting to know each other session in which they had to respond to the answer with an answer to certain questions about themselves, about how they like to work, a little bit about their likes and dislikes and their preferences. And so this allowed us the opportunity to present to participants kind of pre-scripted statements made by either the fake human participant or the fake robotic participant. And by the way, to increase the realism of the situation, we were able to program into the program little things like having the either human or robot say, "It's a beautiful Wednesday afternoon here in Toronto," or corresponding to whatever day of the week it actually was, to try to make foster the illusion that this was actually occurring in real time. And participants also had to make a video of themselves responding to the same questions. So you have this getting to know each other session that corresponds to this design here, right? Where it's so every participant was assigned to one of these cells essentially, right? So their counterpart was either described as having high moral values or low moral values, high autonomy, low autonomy, etc. And was either a human or a robot. So we have this 16 cell between subjects design. And we ran a total of 1,000 people, but after various exclusions based on people who didn't finish or who were repeat participants who tried to participate more than once, it got us down to a little over 800 participants total, which we were able to determine was enough statistical power to detect fairly small effects. Okay, so Let me just
Jason,
stop here.
Can I?
If there's any
Sure.
questions.
Yes. Could I just interrupt for 1 second?
Sure.
So I'm just trying to, and maybe this will become clear as you present more about the experiment. I'm just wondering, how did you implement the idea of a robot having values or social connection or emotions?
Yeah, sure. So I'll read to you a little bit from the scripts, okay? So for example, it starts out when the robot is talking, says, "Hi, my name is Pepper. I'm a personal assistant robot. I was developed in such and such laboratory, and I was designed to play an assortment of interactive games with humans." And then the human version says, "Hi, my name is Laura. I'm a student at the University of Toronto, and I enjoy playing interactive games." Right. And so how do we manipulate values, for example? So values is either Laura or Pepper says, "I hold a clear set of moral values. I recognize right from wrong and make decisions based on those deliberations. I value integrity, trustworthiness, honesty, and loyalty." For low values, the target entity stated either I do not hold a clear set of moral principles. My main focus is to ensure that my personal goals get accomplished, as opposed to deciding what is right and what is wrong for improving the welfare of the human race. Okay, and I don't know if we have time to go through all 8 of these, but so it sort of continues along these lines. So for autonomy, just to kind of briefly summarize it, so I am highly independent and often make choices and take actions to accomplish my goals. Once I've started a task, I am capable of stopping it and moving on to a better course of action. Low autonomy is something along the lines of, I work best when I have clearly spelled out plan to follow, which requires me to make limited choices, et cetera, along those lines. So high social connection is, I have a number of friends. I love to interact with people. Low social connection is I prefer to be alone. Although I can collaborate with people, I work best when I'm operating independently and on my own. Self-aware emotions is high self-aware emotions is I'm good at perceiving the emotions of others. I often display empathy. When I make a mistake, I can feel guilty about it. Low self-aware emotions is I'm focused on my tasks. I have some difficulty when talking about emotions or recognizing emotions in other people. Does that help?
Yeah, very helpful. Terrific. Thanks so much, Jason.
Okay, so that's our main, what we manipulate are our main independent variables. And so our dependent variables, well, first of all, we had some manipulation checks to provide some evidence that these sort of manipulations actually worked. Then we actually counted, participants round 1 move, whether they chose cooperate or compete, and on their round 2 move, and also their ratings of their counterpart. And the important thing to notice here is that round 2 is a little bit different from round 1, because round 1 is made kind of simply immediately after the getting to know each other session. But round 2 has this additional bit of information available to participants, and that is what their counterpart did in round 1. Right? So they have this additional information of knowing whether their counterpart chose the competitive option or the cooperative option in the previous round. And you'll see that comes into play as we move along. Okay, so let's talk a little bit about some plausible hypotheses before I show you the data. So one hypothesis is that a higher level, in other words, kind of the more quote unquote human level on any of the dimensions, should lead to a lower likelihood of choosing the competitive option, the kind of screw your counterpart option. In other words, people like entities that are more human. On the other hand, there's the Uncanny Valley Hypothesis, which might mean that at least for a somewhat high level, the more human level on some of these dimensions, it might lead to higher likelihood of choosing the competitive option, right? The screw your counterpart option. So we're trying to examine, which would better fit the data. So first of all, as I get to the results, the manipulation checks generally worked, and we have a lot of statistical evidence of that. So people were, understood the difference between high values and low values, high autonomy and low autonomy, and their ratings kind of reflected that. They also were able to distinguish between whether they were playing against a human or a robot. What we also found, and the reason why I have round 1 move crossed out there, is we actually find no effects of our manipulation on participants' initial move. So none of the manipulations had any effect on their likelihood of choosing the cooperate option or the compete option at round 1. And so I'll return to that issue later in the talk, because what we do find are some fascinating patterns that emerge at round 2 of the prisoner's dilemma game, and also with the ratings participants give when they're evaluating their counterpart. So let's compare high versus low values in round 2. And here the dependent variable is count, just the number of people who chose the compete versus cooperate option. So at low values, participants did not really make much of a distinction there on the left side between competing or cooperating. They did so with equal likelihood. When it was a human, they were slightly more likely to compete against the low values robot than they were to cooperate with the low values robot. But what happens at high values is you see a big change. So when they're playing against a human, again, no real distinction, no real preference for competing or cooperating. But you see a big change when it comes to playing against the high values robot, and they're much more likely to cooperate and much less likely to compete when they're playing against the robot that expresses high moral values compared to low moral values. And so this was an encouraging effect to us, and it was even bigger than we expected. I mean, participants seemed to really trust the high values robot, and even more than they trusted the high values human. And so this even exceeded our prediction, based on this humanization hypothesis. I mean, we expected at best high values or what have you to equalize the two, right? To bring robots up to the level of the way participants would see humans, but in fact, it led them to trust the robot even more than they trusted the comparable human. And so I'll return later on to why this effect may have occurred. Now, what about high versus low autonomy? What effect did that have on participants' choice of the compete versus cooperative option in round 2? And the answer is nothing. Big goose egg. So we didn't get anything with that. What about social connection? I have a lot of friends versus I don't have a lot of friends. How much does that affect participants' likelihood of choosing the compete versus cooperate option? Nothing. Big goose egg. But what about self-aware emotions? And here's where another place where we did see some interesting effects. So first of all, at low emotional self-awareness, participants were kind of equally likely to compete versus cooperate when they were playing against a robot. They were a little bit more likely to compete against a human. But what happens at high self-awareness? What we see is that the effect kind of flips, and it's the humans that equalize, so in terms of the likelihood of competing versus cooperating. But the robot is where you have this dip. So participants are at high emotional self-awareness. Remember, this is the robot expressing high emotional self-awareness. Participants were more likely to choose the compete option than the cooperate option. And so you can see that this pattern is the opposite of what we find with values. When the robot expresses high values, participants really trusted that robot. When the robot expressed high emotional self-awareness, it seems like the participants were to some degree turned off by the robot. Right, so there's a little summary here. So whereas changing the human's emotional self-awareness from low to high reduced participants' competitiveness, changing the robot's emotional self-awareness from low to high increased participants' competitiveness. And so one possibility of why this may be occurring is that maybe the high self-aware robot is crossing into the uncanny valley. And so I'll return to this a little bit as well. Now, what about the trait rating? So we had people just simply rate on 1 to 7 scales how reliable, ruthless, naive, and surprising they thought their counterpart was. And we see, again, some interesting findings for both values and self-aware emotions. So here the dependent variable here is perceived naivete. So looking on the left side there, you can see for humans, participants, there's no significant difference there. They rated the human equally naive, whether the human expressed high values or low values. But there is a significant difference on the right side of the figure there for robots. When the robot expressed high moral values, participants rated the robot more naive. But for self-aware emotions, you see the exact opposite kind of shape, right? So we see here that at low self-aware emotions, if anything, participants rated the the less naive than high. Participants rated the human with low self-aware emotions less naive than a human with high self-aware emotions, but it's the reverse for the robot. So they rated on the right side there the low self-aware emotions robot as more naive, and the high self-aware emotions robot as less naive. So it's kind of a mirror image as well of what we see with the values manipulation. And so this does tend to correspond a little bit with what we saw with the round 2 prisoner's dilemma choice data as well. It seems that perceived naivete is somehow related to the types of choices that they make. All right, so some questions that we have from the data. And one is, why do participants trust the high values robots so much? Right, this was puzzling to us. And this is where I definitely want to throw it open to you all for some feedback to help me out, to help me understand these data. But one idea that might be plausible that has occurred to us is maybe people expect higher consistency from machines. So what this means is that relative to humans, we expect a good machine to be more reliably good and a bad machine to be more reliably bad. So if a robot expresses goodness, then we can just sort of expect it to be more good, more reliably, more consistency relative to a human who is, after all, susceptible to human frailties. And there's some indirect evidence for this idea. Some recent data from Sharif Rawan shows that people hold an autonomous vehicle to a higher standard of safety than they hold for human drivers. In other words, they kind of seem to expect a higher level of consistent, in this case, good performance. And we can all think about this, in our everyday lives at the, disproportionate rage we feel when the photocopier jams, or when the vending machine, gets stuck with the chips halfway down the slot. This idea, you had one job, right, and you're violating your my expectation for near perfect consistency from you. And maybe that's kind of what's happening here. But we don't really have any evidence to support this idea yet. All right, an additional question that comes from our data is, why this delayed reaction? Like, why didn't we find any effects on the prisoner's dilemma in round 2 and only in round 1? And one reason maybe we can look to some of the classic research in social psychology and social cognition that's provided some evidence that people tend to withhold judgment until they perceive that some sort of mental threshold of evidence has been reached. So for example, in that Darley and Gross paper, they had participants read information about either a high socioeconomic student or a low socioeconomic student. And the information was identical. All that differed was whether the participants were told this person was from a high socioeconomic class or low. And then participants asked to rate their opinion of the student on a series of traits. And at that point, participants rate the high and low socioeconomic student equally positively. But then in another version of this, another condition, participants watch a video of the student taking a test. And you don't actually see the student's score on the test. You're not provided with any additional diagnostic or helpful information. It's actually the same video in both conditions. But now, after watching the video, at that point, participants felt much more justified in rating the high socioeconomic class student higher and more positively than the low socioeconomic class student. In other words, people seem to have this metacognitive sense that I need to withhold judgment until a certain threshold of evidence has been reached. And so maybe that's what was happening in our study, is participants didn't feel entitled to really make any firm decisions about their counterpart until after they had enough evidence to do so. And so that evidence appeared to be supplied by the counterpart's behavior in round 1 of the game. Okay, so a little bit of summarizing. So these data begin to suggest that imbuing a robot with a moral sense fosters trust. But imbuing a robot with high self-awareness, right, seems to hinder trust, at least compared to human controls. So where does this take us? So in the short term, one of the things we're going to be doing is actually doing this in person. As our labs begin to open up, in the process of purchasing my own actual Pepper robot, and we'll be bringing people into the laboratory and having them actually play these types of behavioral economics games in person with an actual robot that we're able to program and control. And in some sense, I'm kind of amazed we got any effects doing this study virtually, online through kind of an online survey platform. And that actually gives me even more hope that we're going to get some nice results with the added vividness of doing this in person. We're also going to extend to other forms of trust games, including a well-known behavioral economics game that's actually called the Trust Game, that has relatively similar kind of underlying structure as Prisoner's Dilemma, but is importantly different from it in a number of ways. And another thing we're going to be really aimed at trying to do is trying to expand the dimensions beyond just 2 levels between high versus low to a full spectrum. Because after all, you need more than 2 levels to demonstrate a valley. If what I'm claiming in the self-aware emotions data is an uncanny valley effect, you need at least 3 levels to demonstrate a valley, and it's not just a linear effect. Then in the longer term, we're going to start to try to come up with more rigorous identification of the dimensions, actually using more rigorous psychometric methods to try to identify what people think are the fundamental dimensions of what makes a human a human. And this might involve adding new dimensions that we haven't thought of beyond this VASS. It may also include coming up with better operationalizations of VAS and S. Remember, we didn't find anything we've got these null effects with the A and the first S, but it may just be because of our manipulation. It may not be because there's just something inherently unmanipulable about that. So we're going to do kind of some more rigorous research on trying to identify the active ingredients that truly manipulate people's understanding of their counterparts' autonomy or social connectedness. My student, one of my grad students, Reem, is doing some interesting work on investigating people's perceptions of a robot's intent and intentionality, and what happens, to what degree do people ascribe intent to a robot? And we're also doing a lot of work, consistent with a lot of work I've done in the past, on sacrificial dilemmas, also known as trolley problems, right, where people are put in the horns of a dilemma where they have to decide whether to sacrifice one person to save 5 other people. And so what happens if that decision maker is a robot? And this is something that is really coming to the fore in everyday discourse nowadays with autonomous vehicles, as we have to think about how do we program them, when it comes to a situation where it may come down to killing one person to save 5 people. Is this something we want these autonomous vehicles to do? And what are the kind of the parameters we need to build into it that make friendly contact with people's intuitions? So this work has some practical implications, especially for, as I mentioned, with autonomous vehicles and how we program them, how we try to increase people's trust with autonomous vehicles. It also has a great deal of implications for work on companion robots. Now more than ever during the pandemic, companion robots have been seen as increasingly helpful and necessary, especially for isolated individuals, to have some sort of companion-like interaction. And so increasingly, robot pets have been prescribed in almost a medical fashion to isolated older individuals who have a hard time getting around or are immunocompromised in some way and just can't risk interaction with people. And so how do we, manipulate the features of these robots to make them more acceptable to people who may actually need them in a medical sense? So beyond the practical implications, I'm also interested in the psycho-philosophical implications. All sorts of interesting questions are raised by this kind of work, like to what extent should we assign moral responsibility to human-like machine actors? So for example, when an autonomous vehicle crashes, how do we allocate the responsibility? How do lay people allocate the responsibility to what percentage goes to, the company, the programmers, the car itself? And so there's been increasing work on trying to understand how people make these allocations. And we're wondering how variations in the quote unquote psychology of the actor may push and pull those distributions of moral responsibility systematically in different directions. And also it raises questions about what are our moral responsibilities toward human-like machines. And there has been some work by researcher Peter Kahn at the University of Washington, who's looked at interesting studies like having people come in to the lab and interacting with a robot pet, and then at some point they're instructed by the experimenters to turn the robot off, but the pet essentially begs for its life and says, "No, please don't turn me off. I want to continue playing. Don't turn me off." Which, coming back to 2001, it was one of the most unnerving and powerful moments of the movie is when Dave the astronaut starts to disconnect HAL, kind of unit by unit there, and HAL says to Dave, "Stop, Dave. What are you doing, Dave? I'm very afraid," right? And starts to really kind of protest against being turned off. And one of the, I think, testament to Kubrick's talent is this idea that we actually begin to feel a tiny smidge of empathy for HAL at this point as he's being disconnected and starts to act a little more and more unhinged. Now, one thing that you're probably thinking throughout this entire time, and I think it's worth raising, is do we actually want to increase trust in robots? So I've been kind of operating on the assumption that more trust is a good thing, but certainly there are a lot of reasons to question that, including research by researchers in the HRI literature who've documented examples of overtrust, and that's their term. So for example, Robinette et al. Brought participants into a lab and had a robot provide instructions for how to leave the room in the event of an emergency. And in one condition, the robot gave instructions that were clearly nonsensical and stupid and circuitous and just obviously made no sense. And what they find is that participants kind of more often than they should have continue to follow the robot's instructions even when they knew better. And so given these examples of overtrust, we need to begin to kind of ask the question, is the problem too little trust or too much? Or maybe the better way to phrase it is, when is there too little or when is there too much? And so all the manipulations I've been talking about in our study need to be tempered a little bit by these kind of considerations of when is trust in robots actually harmful. Okay, so I think that's where I'll stop today. And I'll just turn it over to you all if you have any questions or comments.
Great. Thank you so much, Jason. That really interesting work and very thought-provoking. Really appreciate that. Okay, let's see. Sheila, can I come to you for a question to start us off?
Sure, Jason, thank you so much for such an interesting talk.
Sure.
and indeed a provocative one. And I guess I'd like to start. I have some high-level questions.
Sorry, unprofessional. I had a phone call.
Oh, no problem, no problem. I have some high-level questions and some low-level questions, but your last slide sort of prompted one of the high-level questions I had, which is, of course, there's been a lot of debate. Actually, in the machine learning community in 2018, I think the community as a whole was held to task by a sort of provocative article that was written by Brent Hecht and some other people, talking about how when we do research, you know, in the medical profession, it's often the case that we talk about both the benefits and the threats. And yet in computer science, historically, we've always, and as technologists, we've always talked about all the great properties that we can achieve with the AI that we're building, but not necessarily talk about what the, you know, the societal impacts are. And so I guess I have a couple of questions sort of related to that and related to your last point. For a long time, people have debated whether anthropomorphizing or creating human-like AIs is an appropriate thing to do. And I'm sure you're aware of the debate. I was curious about, to get you to comment on that in a little bit more detail. Certainly it's the case, I don't know, I trust my winter boots to keep my feet dry when I go out in the Canadian winter, and I trust my car to get me from here to Ottawa if I'm driving there, but I don't anthropomorphize those. And so obviously I think we can create trust and understand boundaries without creating human-like robots. And so I'm wondering what your sense of the pros and cons are, and if you can comment about how other ways we might build trust and whether this is the right way to go.
Yeah, I mean, it's a terrific, set of questions there. And so I think, the trust issue is most relevant when we're talking in kind of the moral space, when we're trusting our machine actors to make moral decisions. So whether it's, the choices of an autonomous vehicle, who to kill and who to save, or of course, there's any number of other domains. We're talking about hospital triage protocols, which are, increasingly being decided by algorithms or drone strikes or what have you. So, so I think that's where the trust issue is more relevant than, for example, the boots issue, right? So the boots example is not a moral issue. It's just, will this thing work or not? And so that's why we have to be, and so that's why I think you're spot on in pointing out we do need to think about both the costs and the benefits, and when might the trust in a moral decision-making entity be unwarranted, or at least we have to be super cautious about it.
Yeah, it's interesting. I'll just one more remark and then I'll cede the floor. Yeah. I think there's a continuum. I don't think we can say this is AI, this is not AI. This is AI. We have anti-lock brakes in our cars right now. Those anti-lock brakes are making decisions for us in terms of how we're how the braking system is work. We have computer programs that are controlling nuclear power plants that are
right.
Hopefully protecting us all against catastrophic failure. I guess I guess we're using AI for medical diagnosis in certain cases even right now, and so there are more implications to those decisions. It's a tricky question. I think it's an important one. So I appreciate your comments, and the jury's still out for me.
I agree. And so I think we can think about answering this question at two levels. I mean, one is the level of philosophers and ethicists in trying to and their job is to try to figure out what should be the right answer. But as a psychologist, what we're more interested in is trying to understand what are people's lay beliefs, what are people's intuitions, so that whatever policies are developed do make some kind of friendly contact with folkways, so that whatever principles or laws are developed do resonate with people's intuitions, and then we'll enjoy some kind of popular legitimacy and won't seem strange or out of step with people's wishes. Good.
Thank you.
Great. Thanks. Okay, thanks, Sheila. Thanks, Jason. Nico.
Thank you. Let me take the opportunity very quickly to apologize for having sent that calendar invite. I don't know what happened. I was just responding, and it went to everybody. Sorry about that. Coming to the talk, which was great, I have a couple of questions. So you mentioned you want to try also with other types of games, the public good game, the trust game.
Okay, yeah.
I guess in part that depends on what kind of interaction you are more interested in. You were mentioning, for example, in terms of personal care, but for example, another game that could make sense, and it might be more about the robo-human interaction in a company, for example, in manufacturing or whatever, is games like the public good game, and trying to figure out whether the different parties are willing to contribute to the common effort more, even if they might have the incentive to free ride. So I guess depending on the type of situation, there are a bunch of different games that one could try. And related to that, I was wondering, it's more asking, in general, your view on this, how this relates to the question of not just the anthropomorphism or the value, but also the transparency of the rules of the algorithm that guides the particular machine. So I can think of an extreme where we are told that the robot always cooperates, right? So what would we do as human beings? Might that depend at that point? So might look at the interaction with the physical feature of the robot. No, we know that we can screw the robot all the time. They won't react. Would we do it as opposed to a human being, for example? And so my last point is, again, throughout the talk you were talking about, again, and I use the same term, screwing versus cooperate. I guess one might see screwing also as being rational according to the rules of the game. So one might put it also differently, to what extent we are self-interested as opposed to willing to be fair according to the characteristics of the robot.
Right. And I mean, just addressing that last point, I mean, this is one of the big, kind of tensions between kind of the standard rational choice models of economic decision-making and the, more recent models informed by behavioral economics. Because in study after study, we see evidence that of, humans violating rational choice, right? And violating, acting out of pure self-interest, and actually, in essence, being more morally good than these pure self-interest models would predict. And so that's fascinating. And so what we're essentially asking is, to what extent does that, goodness benefit extend to when you're not playing against another person, but playing against a machine? And then what are the human-like qualities of that machine that really elicit that benefit, and what are the qualities that might actually turn you off and make you more apt to try to screw it over? Like, for example, even in my data that I showed you, participants rated the high values robot as more naive, and at the same time that they were way less likely to screw the more naive robot, right? And
that was really fascinating. Yeah.
I mean, like a pure self-interest model would predict the opposite. The more naive I expect my counterpart to be, the more I'd be willing to screw it. And so we see the opposite there.
Would that work with humans? I mean, it's harder to rate your human counterpart in the same terms, but if you were told, if you told the participants that the counterpart was, didn't know anything about the prisoner's dilemma and so on, or scored very low on a math test, I don't know, would they be more willing to defect as opposed to cooperate? It would be interesting to compare.
Yeah, and I don't know.
I don't know if there is any evidence.
I've actually done that. Yeah.
Exactly. I don't know.
Yeah, but we can just do the kind of a thought experiment. What if you're playing Prisoner's Dilemma against a 5-year-old child? Right. I mean, I think you would, what kind of a person, you have to ask yourself, will just relentlessly just screw the child, right? And so I think to what extent can we imbue this kind of naivete, into a machine?
Can I just ask what Jason, the concept of naivete, and maybe I just missed this when you were presenting it, was that, what was the definition of naivete that you gave?
We just said it's simply, how naive do you think this, your counterpart was, whether it's a robot or a human, and to just rate it on a 1 to 7 scale from not at all to very, very much.
So is your interpretation of that naive is sort of the opposite of strategic, or is it naive the opposite of sophisticated?
One of the other items we had was ruthless, and I was expecting kind of ruthless and naivete to kind of be opposites of each other, but we didn't get any effects with ruthless. But in our minds, we thought naivete is kind of the opposite of ruthless.
Yeah, or just not seeing the opportunities. Oh, I see. I could take advantage of you here if I change my behavior.
Yeah.
Sheila, you want to jump in here as well?
I had another question. I guess it sort of relates to the conversation that's been going on, which is that I put myself in the position of somebody taking your study. And if a Pepper robot had said to me that it had a lot of friends, or it had certain values, or certain, and maybe I'm not quite understanding how those values, how those properties or features were conveyed, but some of them I would believe through the robot's assertion and a statement, and others I would believe were completely unrealistic and were just efforts on the part of the robot to manipulate me. So I could believe that if the robot, for example, I could believe that if the robot said to me, I have high values, that I could believe, somebody programmed the robot to make decisions in a particular way. And so I can believe that the robot really does have high values or low values. But saying that if a robot said to me, I have a lot of friends, or I have, I get hurt easily, or I don't know, whatever, I would find that manipulative and completely implausible, because I would know that the robot has no feelings. And so it brings into question exactly what, how to interpret the results. I guess that was one thing. And then the other thing, I was just as a sort of concrete suggestion for how to test it in a different way, is that if you showed examples of the behavior of the robot that suggested certain behavior, that might be a way for the person and then the person subsequently played prisoner's dilemma with the robot.
Yeah. In fact, that's exactly one of the things we're doing now. Yeah.
Yeah.
So rather than just relying on the robot's word, we try to have it orchestrate a situation where it conveys a good deed, actually performs a good deed, or performs some kind of like self-interested, misses an opportunity to do a good deed. We think that would be even more powerful. And I agree. I think I'm based on everything you said. I mean, in some respects, it makes it amazing we got any results at all, because I expected a lot of our participants to be just as skeptical as you. And so, I think that everything you're saying would kind of work against us getting any effects.
Well, no, it would engender some behavior, but it would provide a different explanation for that behavior. So it might be the case that the proclamation of values could be believed, but the proclamation of emotion or self-awareness of emotion would not be believed, and would engender a form of irritation or a sense of being manipulated that would cause one to want to react aggressively towards the in the experiment. I don't know, just yet another hypothesis, but an interesting one to tease apart maybe.
Yeah, it's also tricky to measure this. I mean, we thought about this, because if you try to ask a question like, to what extent did you really believe, what the robot was saying? I'm afraid just by asking the question, we're going to get people to really say, nah, come on, it's just a robot, right? And we're not going to get enough kind of variability in the responses. And that's why we tried not to, at least at first, kind of, in essence, back participants against the wall and force them to admit that this is just a damn robot. But we need to find some way of exactly what you're saying, of assessing that degree of skepticism.
So the other, I mean, just as another data point, the other thing that I might infer as the user is that, oh, I'm being, this is being recorded and I'm being tested with respect to my, emotional intelligence. So even though I don't believe that the robot is, has these properties, I'm somehow being assessed at how I behave with respect to something that claims to be that way. And so I'm going to react in a particular way because I believe that anyways, that I'm being manipulated and I'm meant to perform in a particular way. It's complicated. To design these experiments.
Yeah, and what you just said there actually applies to pretty much every psychology experiment.
Yeah.
Right, and so it's it's difficult to get around that. Yeah, good. But thanks. I like that idea of several of your ideas there of trying to really get at this skepticism idea. We've been kind of putting it on the back burner, but it sounds like maybe we should put it more on the front burner. Yeah.
Great. Thanks so much, Matt.
Thanks so much. That was super interesting because I'm part of a small group here at U of T working on a kind of a human mimicking conversational agent that is being used for treatment of smoking. So it's as part of this motivational interviewing therapeutic process. And my little part of the group is sort of primarily interested in trust. So we've been thinking a lot about trust. But it's sort of, I was realizing that sort of the way your experiment operated and the way we've been sort of thinking about our part anyway is very different, which is for us, we've been thinking about trust as a sort of a necessary part of the development of a working alliance between the bot and the human. And so the context of that work is really the context of a shared practice where there's some stakes involved really for both, well, for the human, I guess, not so much for the bot, I guess. I mean, our results seem to indicate that at least for human mimicking automations, our standard ways of thinking about trust seem to break down. So the sort of the boots example that I forget if it was who mentioned it. Sheila mentioned previously. Like there seems to be a really specific way to deal with trust within that context. And then there seems to be this more complex way that we think about trust when we're thinking about other humans. But it seems to me that human mimicking bots don't fit easily into either one of those two categories. And that's sort of where a lot of the struggle arises. For us, the reason we're so interested in is because, and this is sort of an intuition on my part really, that if what we attempt to do is simply reproduce elements of trust based on what works for humans in terms of the bot, that will be an unsuccessful strategy. And I'd love to hear your thoughts on that, in particular in relationship to some of these pragmatic cases that you mentioned. Is it the right move to just simply try to like imbue bots with things that make us trust other humans? Or is that actually, as I think Sheila seemed to intimate a little bit, is that a deeply problematic, morally problematic proposition?
Yeah, I mean, I agree with you. I mean, I think well, first of all, I mean, there is the uncanny element, right? And so, I mean, it sounds like what you're saying is that like certain, more human-like features that normally work to foster trust, actually, when you put that into a robot, it turns people off.
Yeah, but I don't think it's uncanny. I don't think it's this sort of disgust idea that the uncanny valley. I think it's actually betrayal. I think people feel betrayed or fooled, or that a attempt to fool them has been made when some of these kind of automatons do things. Like, for example, one says, "Oh yeah, well, I really like Japanese food."
Yeah.
I think people are not, they don't feel disgust at that. They feel like the bot is trying to fool them.
Yeah, that's really interesting. So it sounds like maybe we should begin to add items like resentment, like how much resentment do you feel toward the robot and its makers, right? That they're trying to dupe you. Yeah, so we did not have anything like that, I think. No, that's really helpful. Yeah, thanks. I appreciate that. I also want to hear more about what you guys are doing.
Yeah, I'll reach out.
Yeah.
Super, thanks. Matthew.
Hi, it's great hearing your talk. I just have a couple questions, and I think around this idea of trust, because I know there's an extensive literature talking about trusting in machines, because there's that reliability construct. There's a whole set of factors that go into kind of that things that we do with machines. Like I use kind of a printing press, for instance. There's a reliability. There's this thing of autonomousness. There's an aspect of like I believe it will operate in a certain way, whereas human to human trust is a very different construct. And I'm just wondering, and maybe this will help in the future, is that the threshold for trust in people using these kind of humanized anthropomorphized machines is not just going from or to seeing their similarities to the similarities to humans, but also the dissimilarities to other machines that are being used and utilized. Because it's like I can increase trust in a machine like a computer, and I don't know whether or not that it is up to match like a person, or is it moving away from other machines. Like if I anthropomorphize the computer, do I automatically see it as human, or is it just another aspect, a dimension of machine trust that I'm ultimately manipulating? And I think
Yeah, I mean, so it sounds like, if I'm understanding you correctly, you're suggesting maybe we would also need to add in like another condition where we just have like a just fully mechanical looking machine be the competitor with no humanness injected into it at all.
Right. And
use that as kind of a baseline.
Exactly. And because some of the algorithm trusting research that's coming out now is to say, like, there are aspects of when you have an algorithm that people actually trust the algorithm more than a human. And it's to say is like when we're anthropomorphizing, it's not just the like, hey, we're bringing the machine up to the human level. It's like, no, we're trying to make it like human, rather than just adding a dimension of trust. Maybe adding that baseline would help. Yeah,
that's really helpful. I'm taking notes on this. It's very good. Yeah, thanks.
It's really cool. I believe in that's why I even mentioned something about that.
Great.
That's awesome.
Great, thanks. Yeah.
Whoops, hit that thing twice. Okay, thanks, Matthew. Thanks, Jason. Mina.
Hi, thanks, Jason, for a very interesting presentation. So I had a couple questions, kind of related to sort of the experimental design. So I was wondering why you didn't have, I know that, the outcome here is, or you're using sort of this proxy in terms of looking at whether they cooperate or compete as a proxy for trust, but would it have been interesting potentially to, especially because we looked at a lot of different types of trust, to actually measure trust as an outcome of kind of the decision making. And the other piece for me is, I think when you look at this difference in the values, I think like a lot of other people had felt, it seemed to make sense, right? That you would say, well, for the robot, I think that it's programmed into the, like the values are programmed into the robot already. Therefore, it's normal that I'm going to believe what they say. Versus with a person, you rarely meet someone who says, I really, I have great values, and they actually have great values, right? You just like, you see that from your interaction, and someone who's saying that, I think, creates distrust from the beginning. So I wonder if it might also be worthwhile to collect some qualitative data just to get out into like sort of people's, but why did I act the way that I did? Or why did I trust the robot more or less? Or why was I willing to cooperate or compete with the human in this situation? Like, I feel like when you want to get to sort of the intentionality underlying trust decisions, a lot of times, particularly when it's exploratory work, it could be worthwhile to collect qualitative data as well here.
Yeah, I mean, I really like that idea. And that is something that we've discussed. We haven't really moved too far ahead in that idea. But yeah, I think we do need to flesh out kind of using qualitative data, a more robust and detailed picture of what people mean by trust and how they're interpreting, the statements of the actors. And I mean, what was the first part of your?
Well, it was just, I was wondering because at least from like a management perspective, we have a lot of different types of trust that we usually
Right, yeah,
when you're looking at like cooperation, competition, or rivalry. And why do people, work in teams together, and why do organizations decide to collaborate or compete, all that kind of stuff.
Yeah.
So I just wonder if, it might be worthwhile to kind of take some more direct measures.
Yes, I mean, we're kind of operationalizing trust in the study in a very narrow, circumscribed way. It really just means like trust in the context of this game, like trust that, Pepper won't screw me, and nothing else, right? But I think you're right. I mean, and that's something where the qualitative data could come in, could kind of get a larger picture of different varieties of trust across different domains. I like that idea. That's important to do. Yeah.
And maybe even just in terms of like digging into further, like this measure of naivety, for example, it's also trying to understand like what did the participants understand by that term, right? In this context as well.
Yeah. No, that's good. Yeah. Thanks.
Thanks, Mina. Lisa.
Hi, Jason. Thanks. It was a super interesting talk. I wondered if I could ask you to say a bit more of how you think about, if you do, the relationship between trust and trustworthiness. Because when you were saying at the end of your talk, about some of the questions raised by a lot of this research, is there too much trust, too little trust? I would think, and this is just kind of a layperson reaction, that there's too much trust if you trust where there's no trustworthiness, and there's too little trust if you're not trusting where there's a lot of trustworthiness. And one of the things, I mean, maybe this kind of echoes what some of Sheila's reactions, but I think, I trust the drugs that my doctor prescribes. I trust my doctor. I trust the pharmacist. I trust the drugs that are given because I trust the medical system. I trust the licensing. I trust the drugs approval process. I trust medical devices because I trust the system we have in place, the approvals of it, etc. So there's ways in which we trust these kind of components of really complex systems because we think the systems are trustworthy and they have a lot of different pieces to them. So why don't we do that with robots? Why should we care about whether robots are human-like or not human-like? Why isn't the trustworthiness of, whatever, to take Matt's point, they're kind of part of usually a socio-technical system of some sort. Why aren't we thinking about the trustworthiness of those kind of components of the system, and then how to signal those to people so that people learn how to place their trust properly and not misplace their trust? And if instead we're mimicking what it means to trust a human, in what way is that kind of deceptive in some way that's problematic, because it's not going to connect up to a robust notion of trustworthiness?
Yeah, that's really interesting. I hadn't given that much thought about, like, kind of at the more macro level, institutional level, how much trustworthiness does, say, the robotics industry, deserve compared to like the medical industry, right? In other words, to what extent do I believe that they really have our best interests in mind, or if they're just trying to make a buck? And how much are they driven by just profit motive? And yeah, that's really interesting. And so that has, really interesting implications for, for example, if you want to buy an autonomous Tesla, how much, does it matter to you whether you think that, Elon Musk is a moral person or not, right? I mean, is that kind of what you're driving at? Like, kind of independent of the human-like qualities of the entity itself?
I don't think it matters at all what Elon Musk's morality. I think it matters how we manage, safety issues, and we have a whole complex system. I mean, I'm a lawyer as a background, so I'm like, wow, we build regulatory systems so that people can trust complex systems. And part of what, at least I see in that kind of AI space, but just technology generally, is that we haven't done, we need to do more around this. And so the issue of, whether any particular person is moral or not, I just think, I don't actually see where it makes such a huge difference compared to a lot of other elements.
Well, I didn't mean
we trust a medical device because of the approvals process it goes through and the testing that's done on it, and my belief in that system working well, not about anything about the morality of the inventors.
Right, but we often have to interact with products that haven't gone through that kind of regulatory process, right? Haven't gone through a rigorous regulatory process. And so then the question is, in the absence of that, I mean, I agree that object that has gone to market without a large regulatory process is lower in trustworthiness, right? Just inherently. But the fact is we have to face these things. And often we actually even have to trust them. And so in those cases, how can we push and pull people's trust, even for an object that inherently, I agree, has kind of slipped through. But there's a lot of those. There's a lot of those objects that come out to market with little regulation. Most of those things are operating in the text sphere, right? All the algorithms. There has been insufficient regulation to date, anyway, at least compared to, for example, medical testing. Anyway, good. I mean, I love these ideas, and I think we need to find ways to kind of intersect our work with the kind of more legal, regulatory sphere as well. So thanks for that.
Yeah. Sheila, if you don't mind, I'm just going to insert myself in the queue here. So I guess, so I'm really interested in this work, and I think we've kind of unpacked a bit about, like, there's a difference between your values element and the other three, in the sense that there's a reasonable way to interpret what that means when the robot says, I have these values, because you can interpret it as a programming. But I also want to sort of push on just a theoretical framework for trust. It's part of, I think, what Lisa's sort of getting at, sort of like what is the, Matt is talking about this as well. So when I think about trust, I think about, like, it's really predictions about, can I expect you to follow rules, norms, and so on. There's a small bit that's, do I expect you to be a moral actor, but that's also about following kind of rules of moral behavior. And most of what we're interested in is do I expect you to follow the rules of this situation? So when I think about the uncanny valley, I think that one of the things that it's picking up on is that we are constantly scanning the people in our environment to make predictions. Is that person basically following the rules, like our whole complex set of rules? And if a person is a little off, if they're dressed differently, or they use different words, they behave in an odd way, we don't trust them as much, because it's a signal that, oh, they're not following that rule, so maybe they're not following the rules I really care about. And I think that's part of what's getting picked up with the uncanny valley. But I think the real question is, okay, so what is the basis for predicting how a machine is going to work? Does it have good contextual knowledge of the rules of these circumstances, of the rules of this game? And that can partly be addressed by programming, but we also know the world is very complicated. And, so I think part of what we're picking up on here is a prediction about what's the likelihood that this robot knows the rules of circumstances like this. I'd love to see the experiment conducted with lots of other, you mentioned the trust game, but even these ones are hard ones, as Nico was pointing out earlier on. These are kind of special settings where, lots of people don't trust the other person, and some people think you're a sucker to play the prisoner's dilemma any other way than the rational choice model would predict. But anyway, so I think to kind of that theoretical grounding in, because we need to figure out, how will we have confidence that the machines know the rules of the social circumstances, that we can say, oh, I can, I'm willing to drive on the highway with that machine because I can expect it to behave in the way I expect human drivers to behave, or better. And as you noted, we do expect that. Anyway, it's really just an observation about kind of your starting point with the uncanny valley and like the theorizing of what's happening with trust. I think it's about rule following.
Rule following, yeah. So, are you suggesting that we might be able to create a more trustworthy robot if we have participants interact with it for a while, and the robot sort of continually follows rules and doesn't violate them?
Yeah, and it shows evidence that they know what the rules of this social interaction are, which we've got a lot of confidence and we have another human there. That's why I think the prisoner's dilemma is so hard, because exactly what we see is like, you play that game once. I don't know, Nico, what are the percentages? Like, what percentage of humans cheat when they play prisoner's dilemma in the lab?
Yeah. I mean, it sounds to me what you're saying, I mean, overlaps a lot with the people who are trying to develop, conversational bots, right? Because of, like, one really common type of rule following is conversational rules, and the norms of everyday conversation. And we increasingly are able to be tricked by bots that are learning sophisticated rules about conversation. And we are turned off whenever we see the slightest little violation. I spotted that. A human would never say that.
Yeah.
Good.
Interesting. Sheila.
So one of the things such an interesting conversation, by the way, thank you to everyone. And thank you to Jason for provoking it.
Thank you.
One of the arguments against anthropomorphizing is, of course, that the person who's interacting with the robot or with the AI will ascribe all sorts of human, by assuming that the robot is human-like, by assuming that the AI is human-like, that it will ascribe all sorts of capabilities to the robot that the robot does not have, or infer all sorts of other performance capabilities that it really doesn't have, and in that way really make it dangerous for the human being, because it will a more general comment that's been criticism that's been wielded against anthropomorphizing for a long time. And I wonder whether there's an interesting question in understanding how you can actually build a robot personality that is circumscribed in the same way that to Lisa's point, my trustworthiness with my trust with respect to a medical device, or my trust with respect to my car, or my trust with respect to the spaceship that's going to take me to Mars, provides me without the need for anthropomorphizing, which causes us to extend our trust into regions where we should not have trust. And I wonder whether there's a way to understand how to control that, in the same way that we do understand the limits of human beings. They communicate those limits to us, and we understand how to then have reasonable expectations about what humans can do. And maybe there's some way to get your cake and eat it too. Anyways, just a comment, but and I'm turning my microphone off. I would wonder what you think.
Yeah, well, no, I like that. I mean, I think, as I mentioned, we do need to be very careful about when the trust is appropriate and when it's overextending it into an area where it doesn't belong. And and I think that's something as a society we need to hash out. And this is where ethics and psychology and engineering have to kind of come together and actually have these debates and have these discussions and create legislation, create regulatory frameworks that are consistent with what emerges. And that's obviously easier said than done, but I think that's kind of an absolutely essential discussion that needs to take place. Yeah, great, okay. Thanks.
Thank you. And Beatrice.
Yeah, thank you very much for this. This was super interesting. I hope I'm going to be able to ask a question that actually makes sense, because I think this is complex. I've been trying to think, because this relates a lot to some of my work, although in an entirely different context, which is mostly trade, and how, I actually have been using prisoner's dilemma to see how you convince people that the trade can be beneficial and that it's positive sum and not zero sum. So I've been trying to apply that to what you're saying, but I think this really depends about what the ultimate aim is, right? Like, is it just about increasing humans' willingness to engage with robots, or it's just about increasing trust? Because if it's about increasing humans' willingness to engage with robots, then you could also use the prisoner's dilemma, the repeated one, to convince them that it's a positive sum game, that it's actually a positive sum interaction. So you could tell them that the robot is going to play a tit for tat strategy in which as soon as the human starts defecting, then the robot is going to start defecting at the next round. And the same if the robot cooperates, the human cooperates, the robot is going to continue cooperating. So basically you could introduce some kind of like mechanism that so that the robot rewards cooperation and punishes defection over time. And you could like instruct individuals to tell them that if they maximize their score, then they actually get a prize or something, so that they have an incentive to cooperate if they know that the robot is going to play. So I was wondering, I guess this relates also to what the ultimate aim is, but if it's about like increasing humans' willingness to engage with robots, like this could be a way to basically teach them that it's a positive sum exchange and not a zero-sum one. And this could also increase trust, maybe not like indirectly, but this was super fascinating. Thank you.
Yeah. I mean, to answer your point, I mean, I want to make it clear that our aim isn't to try to just overall just increase trust in robots, right? We're trying to be dispassionate about it and just trying to uncover what are those variables that do increase trust and what are those variables that do decrease trust. We don't really have the same kind of, end game that engineers have, which in general is to just try to increase trust. And so, I mean, but yeah, so I do want to make that clear. But I like your idea that increasing engagement is not the same thing as increasing trust. And there are ways to increase engagement independent of the trust avenue. I like that as well. Yeah. That's interesting. And I mean, it's something we do have, on the back burner, is to try to play the game out over multiple rounds, like maybe, 15, 20 rounds, and really see how the trajectory develops over time, and to manipulate different patterns that the counterpart can play, including, a tit for tat pattern or relentlessly cooperating pattern, relentlessly defecting pattern, and all the different options. Yeah, that's great. Yeah, thanks.
Okay. All right. Well, that's been a really lively and very thought-provoking, as I say, conversation. Thank you so much for fostering that, Jason. And I think, as you see, there's lots of us in this group who are thinking about trust and theorizing about trust, and maybe we should have a discussion group on trust. I think we've got some.
Yeah, I learned so much today. Thanks so much.
Yeah, because I think it is such a critical piece of understanding the design of those regulatory systems, our licensing systems, and the risks that we face. And I think, just more sophisticated thinking about trust is really critical to the project of safe and beneficial AI. So thank you very much. So I want, Jack popped into the chat a very short little survey. I would very much appreciate your feedback on the session so we can continue to improve, and you can trust us to do well by you. So help us to do that. And I want to invite you to join us, both to thank Jason for his talk, and also invite you to join us next week for our talk from our faculty affiliate, Kelly Lyons from the iSchool, on evaluating the future of skills, jobs, and policies for the post-COVID digital economy. I'll look forward to seeing you all next Wednesday. Thanks again. Bye.